So what we're going to do in this video is several examples where we evaluate expressions with definite integrals. And so right over here we have the definite integral from -2 to 3 of 2f of x dx plus the definite integral from 3 to 7 of 3f of x dx. And all we know about f of x is the graph of y equals f of x from x equals -6 to x equals 7. They also give us the areas between f of x, y equals f of x, and the x-axis. The negative areas show that our function is below the x-axis. And so given that, can we evaluate that? And like always, pause the video and see if you can do it on your own. Well, the first thing that my brain wants to do is I want to take these constants out of the integral, because then once they're out and I'm just taking the straight up definite integrals of f of x, I can relate that to the areas over here. And I know I can do that, and this is a very common integration property and applies to definite and indefinite integrals. But if I'm taking the integral of k f of x dx, this is the same thing as k times the integral of f of x dx. So let's just apply that property there, which is really you're taking the scalar outside of the integral, to say this is going to be the same thing as 2 times the definite integral from -2 to 3 of f of x dx plus 3 times the integral from 3 to 7 of f of x dx. All right, now can we evaluate these things? So what is this going to be? The definite integral from -2 to 3 of f of x dx. Well, we can view that as the area between the curves y equals f of x and the x-axis between x equals -2 and x equals 3. So between x equals 2 and x equals 3, they give us the area between y equals f of x and the x-axis. It is 7. So this thing over here is 7. And then we have the integral from 3 to 7 of f of x. So we're going to go from 3 to 7. And once again, well, this is going to evaluate to a negative value because f of x is below the x-axis there, and it's going to evaluate to -3. So this is all going to be, 2 times 7, so 14 plus 3 times -3, so plus -9. And so 14 minus 9 is equal to 5. This is fun. Let's do more of these. All right. Okay. So here, this first integral, the integral from 0 to 5 of f of x d of x. So this is pretty straightforward. This right over here, we're going to go from 0 to 5, 0 to 5, and of f of x d of x dx. So we're talking about this area there, which they tell us is 4. So that was pretty easy to evaluate. And now we're going to subtract. We're going to subtract going from -8 to -4 times 2f of x. Well, let's just take this 2 outside. So if we just take this 2 outside, then this just becomes the integral from -8 to -4 of f of x. And so this thing right over here evaluates to 5. It's this area they're talking about. So this is all going to simplify to 4 minus that 2 that we brought out, minus 2 times 5, which is equal to, let's see, 4 minus 10, which is equal to -6. All right, let's do another one of these. So here I have the integral from -7 to -5. So I'm going from -7 to -5, which is, it's going to be right around there. So I want to find this area right over here. So I want to find that area. That's that. And then I'm going to go from -5 to 0. So then this is going to be going from -5 to 0. So it's going to be all of that. Now, there's a couple of ways you could think about doing it. You could assume I have some symmetry here, and they don't tell it for sure, but it looks very symmetric around x equals -5, so you could assume that this 8 is split between these two regions. But an easier way to do it is just to realize, look, I'm going from -7 to -5, and then from -5 to 0, and I'm integrating the same thing, f of x dx. So this integral I can rewrite as the integral from -7, so -7 all the way to 0 of f of x dx. And so really that's just going to be the net area between -7 and 0. And so we have the positive 8 there. So this is going to be equal to the positive 8. And then we have the -1 there. So -1, which is equal to 7.